So, in our discussions about financial mathematics, there have been some difficulties that people have run into with this idea of equivalent interest. So, I'm going to talk through starting with very simple concepts and then building up to the most difficult version. So, let's start off with the simplest situation, which is let's say we have the bank is offering 12% per annum, which means per year. So the bank is offering 12% per annum compounded annually. Okay, so what does that mean? Compounded 12% per annum, this part is simply saying per annum when you see that, or if it just had a /a, that is per year. And compounded annually means that the interest will be calculated once in each year. So we've got annual interest of 12% per year, and the interest is calculated once per year. So that's obviously that's the simplest case we could possibly have. And so if we wanted to calculate how much interest we were going to make, we would, or how much our investment would be worth, we would say that the amount of the investment would be equal to the principal multiplied by 1 plus I to the power n, where in this case I is going to be the rate of interest per compounding period. So in this case that's going to be 0.12, and n would be the number of years. So in this case, let's just say 1 year. And so we would do this calculation and we would end up with something. I'm not even going to bother putting in values here. We would end up with the principal multiplied by 1 plus 0.12 to the power 1. And that is equal to simply the principal 1.12 to the power 1, which is simply 1.12. So when we take a look at this result, you can see here that the principal is going to be multiplied by 1.12, and the 12% is contained right there. So there's the 12% from the interest that we're being offered. Now, how does that change things, and how does it change the way the bank is thinking about things if we change this around a little bit? So let's set up another scenario, almost as simple, which is the bank offers 12% per annum, but this time let's have it compounded monthly. Okay, so actually, you know what? Let's. I'm going to try to gear this towards a better example. This will be more in line with what we've covered in class. So we're going to say compound semi-annually. So how does this compare to our previous example? Really, the biggest difference is here we had compounded annually, which meant it was calculated once per year. And so now semi-annually means we are going to do 2 calculations per year. Otherwise, we've got 12% per year. Now, in this case, things are going to change, because if the bank is offering me 12% per annum, then that means if I'm doing 2 calculations per year, then really what the bank is offering me is 6% every 6 months. So if we get 12% per year, but it's calculated semi-annually, they're going to do 2 calculations per year. Each one of those calculations will be 6 months. And the bank knows this, in making this offer, they're basically saying that we're going to phrase it this way. We're going to call it 12% per year, compounded semi-annually, but the bank actually understands that they're going to be paying more than 12% per year. And in this case, so what would that calculation look like? The amount is going to be equal to the principal multiplied by 1 plus I to the exponent n. And again, I'm just going to do the calculation for a single year. And in this case, I'm going to end up with the principal multiplied by 1 plus. Now, in this case, my I value is going to be the 12% that they originally offered, but with the understanding that there's going to be 2 payments per year. So the 12% per annum goes there, and the idea of 2 calculations per year goes here. And so I end up with, as you can see, 0.12 divided by 2 is going to work out to be 0.06. And so I end up with 0.06 here, and I'm going to have 2, and I guess I can put that there as well, these 2 calculations per year. That's going to go there, so I end up with 2 calculations per year. Another way you can write this, and again in class, this is how we've done it, which is you could write this as 0.12 divided by 2. Both of those are fine. They'll work out to be the same thing. And so when I actually determine what this is, so 1 plus 0. You know what, let's just go ahead and leave it in that form. And then when I do my calculation, I end up with 1.06 squared, and that works out to be 1.1236. And it would be nice, for your own sake, if you were comfortable with seeing the percentages here. Something, again, we've talked about in class is that this 1 represents the 100% of the principal. That's the initial amount you put in. And that means that what remains, that actually represents the interest you are being paid. So this is 12.36% interest. So in offering us 12% per year, compounded semi-annually, the bank is actually paying us 12.36% interest over the full year because of these 2 calculations. And the bank, again, the bank knows this. They're well aware of it. It's built in. They factored this into all of their considerations for profit and loss. We're not taking advantage of the bank. The bank is not allowing themselves to be taken advantage of in this way. They know what they're doing. So let's go on to the third example. And the reason the third example comes up has to do with mortgages. So I'm going to move to a new page. And so now we've got scenario 3, which is the bank offers, and once again I'm going to say 12% per year per annum, and it's compounded semi-annually, so that part hasn't changed. And if you're familiar with Canadian mortgages, you know that compounding semi-annually, that's required by law. But let's now add one other piece of information, and the thing that changes it is we want to have payments monthly. Now the problem, or the reason why we have to now do a special consideration, is that these 2 do not match. And because they don't match, we have to add to this an extra level of complexity. So normally we would look at the amount. If this was just, again, I'm just looking at this in the simplest sense. An amount is equal to the principal plus 1 plus I to the n. So you would think that in this case, if all we do is look at this from the perspective of the interest, I've already looked at this before, and I don't really need to consider the amount or the principal anymore. What really matters is this idea of 1 plus I to the n. And in this case, 1 plus I to the n is 1 plus 0.12 divided by 2 all to the power 2. And that's just like we did in the previous page, in the previous example. Right here, we ended up with 0.12 divided by 2 all to the power 2. And so we're going to end up with the same result we had before, which is 1.1236. So basically, this is the rate of interest required by the bank. They're not willing to change this any further. They've advertised it as 12% per year or per annum, compounded semi-annually. They know that that means 1.1236. But if you want to think about this in terms of monthly payments or weekly payments or daily payments, the bank, that doesn't change the fact that the interest generated is going to be 12.36%. 12.36%. But because we're talking about things monthly as opposed to maybe semi-annually, we have to somehow come up with another equivalent interest. Now, the obvious thing to do here would be to say, well, isn't it reasonable? So let's propose one option, which is going to be incorrect, but I'm going to put it down here anyway so we can see it. So let's consider 0.1236 divided by 12. Right? Can't I just take this 12.36% and divide it by 12? Doesn't that work out? But it doesn't, because if we look at the interest over 12 months, that would be 0.1236 divided by 12. We would add 1 to that the way we always have, and then we would raise that to the exponent 12 for 12 payments. And if you check that, I'll do the calculation now, and you can check that yourself. And when I do this, I end up with 1.1308, approximately 1.1308. And this part, the 1, is 100%. And this part must mean that we have 13.08%. But 13.08%, after you've done the calculation, this would have generated an interest rate of 13.08% over the whole year. But it is required that the interest rate actually work out to be 12.36%. So this cannot be correct. That can't be the interest every month, because that results in a number that's even bigger. So if that's not the case, so if this doesn't work, then what do? We have to come up with some other interest rate. So now let's say we're going to consider some other interest rate. I'm going to call it IEQ, which is the equivalent interest rate. So what we need is that 1 plus IEQ to the exponent 12. So whatever this equivalent interest rate is, if I compound it over 12 months, I have to end up with that interest rate which is specified by the bank, which is 12.36%. And the way I could write that is I need this to be equal to 1.1236 12.36. So again, just keep this in mind. That is the 12.36% required by the bank. So how do we get this? Well, from the equation I have right now, the way I would simplify this is I would take the 12th root of each side, which is the same as raising everything to the power 1 over 12. So you could write it this way: 1 plus I equivalent is equal to the 12th root of 1.1236. Or you could write this as 1 plus I equivalent is equal to 1.1236 to the exponent 1 over 12. Both of those are equally good. And so I equivalent is going to be, and I'm going to subtract 1 from both sides, and I'm going to use this to find I equivalent. And if I go through it, in this case, I end up with 1.1236 to the exponent 1 over 12, and then I subtract 1, and in this case I actually end up with 0.00976, and that's an approximate value. And so that is, so what does that mean? When we're trying to turn this into a percentage, we're going to multiply by 100, so I'm going to move over 2 decimal places. So that really means 0.976% per month. So the equivalent interest to get me to the exact same result of 12.36% over the course of the year is 0.976% per month. Now the way I did this, I did some intermediate calculations, and so I actually used, when I used this value 1.1236, we had calculated it before. Is there a more elegant way to do this? There is. So let me just once again rephrase this, or look at this again. Just writing it out quickly, it's 12% per annum, compounded semi-annually, and we're talking about monthly payments. And so now if I want to look at my equivalent interest, so what I end up with is that I can write an equation that 1 plus the equivalent interest raised to the power, monthly payments means 12, and that's where this 12 comes from, equals 1 plus, and now we're going to put in the bank's annual interest, give that a new color, 0.12, and that's this one, 0.12 per year, but that's actually compounded semi-annually, means 2 calculations per year. So 2 calculations per year means I take this value, 0.12, and I divide it by 2. And it also means that I raise this side to the exponent 2. So hopefully that's clear enough to you, the color coding, where those different values are coming from. And now I can figure out my equivalent interest using this equation. Now this equation actually results in some more algebraic simplification, because you notice I've got something to the power 12, something to the power 2. So if I take both sides and I actually take the 12th root of both sides, or I raise both sides, which is how I'm going to write it, I'm going to raise both sides to the power 1 over 2, or 1 over 12. So I'm going to rewrite this: 1 plus I equivalent to the 12 equals 1 plus 0.12 over 2, all squared, and I'm going to raise both of them to the 1 over 12. Whatever I do to one side, I do to the other side. The 12 and the 1 over 12, well, 12 times 1 is 12. 12 over 12 is 1. That means this whole exponent just becomes 1. So this whole thing just becomes the exponent 1, whereas this one, 2 over 12, this whole exponent just becomes 1 over 6. And so now I can write this as 1 plus I equivalent is equal to, I end up with 1 plus 0.12 over 2 to the power 1 over 6. Or I could finally simplify this as I equivalent equals 1 plus 0.12 over 2 to the power 1 over 6 minus 1. And I end up with the exact same value I did before, which is 0.009. What was that value? 976 for the equivalent interest. Okay, I hope that was helpful. I hope that gives you maybe a new perspective, or you get a chance to look at this a couple of times and it helps make some sense of the idea of equivalent interest, why we need to do it, and how we go about doing it.